Okay, so here you can see I have written a very simple Python code to showcase the difference between the normalization technique and standardization technique. So what actually I have done, I have created a data frame using a data set having all this data. And just to clarify, I'm just trying to print the data frame. You see, so we have total 5 instances having gender and many other features, and say suffer from disease. This is the output, which I have represented by no and yes. Maybe in future we have to represent this by 0 and 1. Anyway, so right now, anyway, my machine learning model creation is not important for me. What my important is that I want to scale all these different features into a same range, which is extremely vital because we can see from this data set that this salary feature is going to dominate most of the features in the dataset because salary is very high. That I don't want. So the first one that I have shown you here is applying normalization technique. So what I have done, you see, for if you want to apply normalization technique, there is a specific, you can say, class min max scalar under this package sklearn.preprocessing that you can initialize something like this. And what I have written here is that I have listed those set of columns on which I want to apply this normalization technique. And for normalizing, we just have to call by the instance name dot fit transform function, and within that we have to pass the data frame. So what I have written, df1 within third bracket calls. What does it mean? It means that the data frame having only these columns, because I don't want to, scale this suffer from disease part because this is an output. That's why you see I have excluded that particular column in this set. I've kept only the HSCP, SSCP, age, height, and salary. That's all. Even not even gender, because gender does not have any numerical value. It's a issue. Anyway, we will see how to resolve this issue in later stage. So that's why you cannot normalize or standardize this particular feature gender, right? Because you can apply only this normalization or standardization on those features which has some numerical values. So that's why I have listed those columns having numerical values, and then I've applied the data frame having only numerical values columns. And once you will do this, and if I print this particular thing, that you see whatever data that I had has been converted into some specific range. And interestingly, you see here, if you look into only the salary feature, you see 21,000 is the highest salary and 5,000 is the lowest one. You will see here 21,000 become 1 and 5,000 becomes 0. That I just showed you. By equation, it should be. And all the other salaries in between highest and lowest is in some range in between 0 and 1. Right? Something like this. And similar thing happened for all the cases. So for all the other columns, you will see there is at least one case where you have value 1 and one case where you have value 0. And for the other cases, it's in between 1 and 0. You see, for HSCP, it's 1 and 0 here. For SSCP, it's 1 and 0 again here. For age, again 1 and 0 here. And for height, the 1 is here and 0 is here. So this is all about the technique of normalization. Now if I want to do the same but using standardization technique, that means I need the you can say standard deviation and the mean. You don't need to find standard deviation and mean. You just have to call in a very simple way the fit transform function of the instance of standard scalar class, again present in scalar.preprocessing package. In the same way, you see the code is almost same. Only difference is instead of having min max scalar, I am writing standard scalar. And in a similar way, I am creating a instance of standard scalar class, and on the instance I am calling fit transform function, and I am passing the data frame again, having those columns having numerical values. And if you run this time, you will see it's not like you are getting value in between 0 and 1. You see, no, because it's not depends on your minimum and maximum value. It depends on the distribution. That's why you cannot guarantee that your range will be always in between 0 and 1. There will be some value in negative as well. But remember, in this case also, the problem that we faced in my original data set, that is salary is very high, which is definitely going to dominate other features. Even HSC value is also little high, SSC is also high, that are going to be in the same range over here. So all the features will have similar impact for classifying based on this data set. So this is the benefit that we can get by feature scaling. So this is basically the very basic idea of feature scaling is, and maybe we can go further detail in future whenever required. Now what we can do, we can again go back to our study, because there is one more data processing technique is left, which is encoding categorical data. You see here, this gender is a categorical data. You can say, why categorical? Because it does not have any value. It has M or F. Question is that how you will put this in your machine learning model, because any machine learning model can accept only numerical value, but M is not a numerical value. So I have to do something to place this gender as a feature in my model, and that is what actually we call encoding this categorical data. This is a categorical data. So let's see how we can do that.